everyone, my name is Anushka Praveen, and today I'm going to be talking about the implications of neurology on enhancing glaucoma diagnostics. About me, I'm an 11th grader at Foothill High School, and I love neurology and public health. Some of my extracurriculars include a research project, a systematic review on glaucoma, an internship at my county's healthcare service agency, volunteering, science bowl coaching, and being a club officer for multiple clubs. My hobbies include graphic design, photography, running, and playing the guitar. What am I going to be talking about today? The world's leading cause of irreversible blindness, glaucoma. This essentially arises due to a buildup of aqueous humor, which is a liquid in the eye. This causes a lot of intraocular pressure, which degenerates the optic nerve that runs from the brain to the eye. This can lead to eventual blindness. There's a lot of risk factors, including the inhibiting of aqueous humor drainage, high intraocular pressure, old age, frailty, hypertension, etc. A lot of the treatments listed here help by mimicking or inhibiting the nervous system by minimizing aqueous humor production or minimizing intraocular pressure. But why is this a global issue? As you can see here, there's multiple cases around the world: China, India, Europe, Africa, and more. And these cases are in the millions. But there's a problem. Glaucoma is a silent blinder because there's no noticeable symptoms in the early stages. This is a problem as a global leading cause of irreversible blindness. There's a lot of gaps in diagnostics and symptoms as well, such as the fact that 50% of patients have normal intraocular pressure ranges until advanced stages of glaucoma and degeneration. The listed symptoms only focus on visual defects, and so they are perhaps limited. This can lead to a lot of problems such as undiagnosed cases, inaccurate family histories, and more. But we need early diagnosis. We need research on other non-visual neurological effects that come with glaucoma in order to introduce new symptoms aiding early diagnosis, which is what my systematic literature review is on, examining neurology and glaucoma. So here are some findings. There's low functional connectivity in non-visual regions according to many experiments. For example, an experiment in 2019 showed results of a lack of functional connectivity between the supramarginal gyrus in the brain and the superior sensory motor regions. There's also been found to have negative communication and lack of functional connectivity between the visual networks and the supramarginal gyrus in glaucoma brains as well. Another study found that in the most common form of glaucoma, there's low functional connectivity between the visual networks and the superior frontal gyrus. Along with functional connectivity issues, there's reduced amount of bold signals. What bold signals do essentially is measure the changes or increases and decreases in the amount of oxygenated blood. What this means is there's a reduced amount of flow of oxygenated blood to the regions aforementioned. There's also found to have white and gray matter damage. What are white and gray matter? They're networks in the nervous system that conduct nerve signals, communication, and information processing. Some of the found damage, as you can see in this MRI image, is problems with the SLF, which is known as the superior longitudinal fasciculus. And this fasciculus has white matter integrity damage around the SMG, which is a region mentioned before. The SLF contributes to a lot of visual processing by integrating spatial information and awareness. There's other regions that have found to have white matter damage in glaucoma, such as the corticospinal tract, the middle cerebellar peduncle, and the anterior thalamic radiation. There's also gray matter damage found in the superior parietal lobule. But what do all of these regions do, and what does damage to them mean? Well, starting with the SMG, which has been mentioned a lot, it deals with language, but experimental results show that its lack of functional connectivity with the visual occipital areas lead to a decline in postural control. There's a similar theme with every single other region mentioned. Every other region mentioned, whether it be low functional connectivity or damaged gray and white matter, all deal with motor processing, balance, executive functioning, spatial processing, and more. What does this mean? The result is a lack of motor control in terms of balance. So there's a loss of spatial awareness, balance, and thus perhaps increased falling. So what does this potentially mean? This could mean that new symptoms are improper balance, increased falling, navigation, lack of orientation, and improper gait or walking. So how can we test for these symptoms with glaucoma? Timed up and go tests, the Berg balance scale, and the POMA test. All of these tests are medical tests that test walking ability, balance ability, and postural control. But why is this efficient? This involves no additional technology or unaffordable technology. This is feasible, cost efficient, and provide additional symptoms that can be new markers of glaucoma, allowing earlier diagnostics. So what can be done? In order to actually establish these new symptoms, we need to fund additional neurological research into these affected parts of the brain and thus adapt our diagnostic tests for glaucoma. Next, we need awareness posters such as this one by a UN subbody. These posters need to print out symptoms, including the new symptoms, and spread them on social media and across all the countries. Lastly, we need diagnostic funding. We need worldwide fundraisers and nonprofit objectives in order to raise money, not just for the advancement of glaucoma diagnostic tests, but also to help fund medical centers and professionals in around the world. So, what is the objective here? The objective of the systematic review is to help early diagnostics of glaucoma, which is the world's leading cause of irreversible blindness. Because there's many neurological effects to be found in non-visual and balance and postural related brain regions, this means that damage to them means symptoms of improper balance, improper walking. These new symptoms could allow us to further early diagnosis, and thus we can help global health because we can increase the diagnostics and thus treatment efficiencies on the world's leading cause of blindness. Here are my references. And I'd like to thank my mentor, Catherine Cording, for her support in the completion of my literature review. I also would like to thank my family and the Johns Hopkins University's Global Health Leadership Conference for this opportunity. Thank you.